Okay. All right, so today we're looking at the composition of functions. What's important is that we can evaluate the composition of two or more functions and that we can construct a representation of a composition of two or more functions. There's a few bits and pieces we're going to work with. We're going to work with the analytical representation of composite functions. We're going to practice evaluating them, and we'll understand that composition of functions is not commutative. And then lastly, we're going to do a couple of other things as well, but 3 goals was enough. You need to find the domain of a composite function. I think it's the hardest part. I'll save that for the end. So just to remind you, hopefully you've seen composite functions before. We do this in IM2. We do it in IM2 early on, composition of functions. And there's 2 ways that we can read it. We can have this format, a notation, which means f of g of x. And then we can use this format. I think this format is a bit easier, f of g of x. I generally will convert from that format into this format. So first we evaluate the inner function, then we evaluate the outer function. So in the case of this one here, we start by evaluating the inner function, and then we evaluate the outer function. In the case of this one here, that just means right to left. So we start by evaluating the first function or the inner function, then we evaluate the outer function. So it's left to right, it's right to left. Let's have a go at some examples, some easy ones. So I'll have a go at the first one and I'll let you do the other 2. So for this first one, for A, we need to find f of g of 3. So what this means is, I'll show it in a couple of ways. A function can look like a machine, like this one. And the function here is the function g, and the function here is the function f. We start by feeding 3 into the function g. What comes out of it is the output gets fed back into f, and then we get the output coming out of here. So firstly, we need to find g of 3. That would mean we've got 2 bracket 3 plus 1, which gives us 6 plus 1, which is equal to 7. So out of there goes 7. So into f goes the value of 7. F is there, so that's going to be 3 times 7 minus 5. 3 7's 21, minus 5, 16. So coming out of there is going to be 16. So the output from G goes into F as the new input. Have a go at finding G of F of 3 and F of 4. I'll give you 2 minutes for this one. All right, have a look at our answers here. So for B, we need to find f of 3, which is going to be 3 times 3 minus 5. So 9 minus 5 is 4. So then we find g of 4, and that's 2 times 4 plus 1. That's 7. So g of f of 3, oh, it is 9, is 9. Let's find f of 4. So we get 3 times 4 minus 5. So 12 minus 5 is what? 7. So then we find f of 7. And we get 3 times 7 minus 5. What's that going to give us? 16. So f of 4 is equal to 16. Notice in this question here, we find f of g of 3. And in this question here, we find g of f of 3. But the answers aren't the same. this means that functions composition is not commutative. Commutative is like you can do it in any order. 3 times 4 is the same as 4 times 3. But the composition of functions doesn't work this way. It's not commutative. We'll see that here with this one. I'll do the first one for you, let you do the second one. So using the equations we've got above, we need to find the algebraic expression for this. So f of g of x is equal to f of, and we can replace g of x with its expression, which is 2x plus 1. And then that's going to give us, then into that we put it into f. So we get 3 bracket 2x plus 1 minus 5. Expand and simplify our bracket. 2 3s are 6, x. 3 minus 5 is minus 2. So here is our answer. Have a go at B. Let's continue. All right, so what did we get here for this one? So we need to put in, we need to put f of x into g, and f of x is, it's up here, 3x minus 5. And then that means our g of x is 2 bracket, and we put in place of x, we put in the input, plus 1. So 2 3s are 6, we get 6x. 2 times minus 5 is minus 10, plus 1, which gives us 6x minus 9. Did we get this? Yes. Notice again that this expression here is not the same as this expression here. These are both examples of how it is not commutative. All right, a little bit trickier here. Let's have a go straight for yourselves. Have a go at these ones for yourself. 6 minutes for this one. All right, given the functions above, find the following values. So here we need to do k, oops. Let me do a here. So we need k of h of 2, which means we need k of, what is h of 2? This is going to be 1. Do we need to explain that? We need k of 2 bracket, we're putting 2 into it, minus 3, which would give us 1. What's k of 1 going to be? We're going to get 1 squared plus 4 times 1 plus 5, sorry. So that's going to give us 10. Synonym. Can only disappoint me so many times in one day, synonym. All right. Let's do h of m of minus 1. So we need h of m of minus 1, which means we need h of, where's m? M is over here. We need h of 3 bracket minus 1 plus 2. We need, what's that? That's going to be minus 1. H of minus 1, where's h? It's over here. We need 2 bracket minus 1 minus 3 minus 5. So C, we need k of p of x. Nice. So we need k of, where's b? It's root 3x plus 1. And then where's k? Ooh. We got to pop this in twice. So we've got root of 3x plus 1 all squared plus 4 bracket root 3x plus 1 plus 5. So that square root will cancel. We get 3x plus 1. But this one's not going to. We're going to get 4 root 3x plus 1 plus 5. We can simplify this to 3x plus 4 root 3x plus 1 plus 6. Is there any other simplification we want to do? No. We could move this 4 inside the root if we wanted to, couldn't we? If we wanted to expand it into the root, what would we multiply the root through by? 16. Yeah. I wouldn't include, but because we often look at multiple representations, I'll just mention it here. I wouldn't think this is required, but if we wanted to bring it in, it comes in like this. Explain to the person next to you why, if we're bringing that 4 in, it comes in like this. Explain it to the person next to you. Sam, John, we good? You're joking, aren't you? What's the square root of 16? I'm coming back to that.
No, but it's not. It's not like I don't understand. Where here it's like.
Hold on. Okay, let's go on to the next ones. Discuss with your partners, have a look at these ones. I'll pause the video for 5 minutes. You can try and have a think through these questions here. Okay, so in this first one, we need to find f of g of 2. So g of 2, well, we start here. That's g of 2 is going to be 3. So this means we need f of 3. F of 3, we're going to be there. We go up there at that point. So f of 3 is 1. Let's try B. We need h of f of 8. So f of 8 now. Where's 8 is here. We're going to come down to there. That's going to give us -1. Yeah, I doubt it will. We need h of -1 now. So -1 is going to be given in this piecewise function by this first expression here, isn't it? If we're putting -1, if we look at the domain there, this is for any x input that is less than 1. So -1 is less than 1. So we're putting -1 in here. So that's going to give us the absolute value of -7 plus 3 bracket -1 is going in there. Close bracket. This gives us -7 minus 3, which is the absolute value of -10, which is 10. So our last one here we need is g of k of 0. It's an absolute value function.
all the values inside that, once you reach the all calculations, if it's negative, it's positive. If it's positive, it stays positive.
How do you determine if it's an absolute value?
The two lines is you see two lines outside. 7.
Oh, okay.
Thank you, guys. So we need to put 0 into k. So what is k? K is a quadratic function, horizontal translation 2 followed by vertical. So let's write up an expression for k. K is going to be x. We've got a horizontal translation of 2 and then a vertical translation of -3. So that's k. So if we put 0 into this, we are going to get g of 0 minus 2 squared minus 3, which is g of 4 minus 3, which is g of 1. Is that right? Yeah. I haven't finished yet, mate. Okay, so we're trying to put 1 into this function here at the top. But if we look at this function here, g is not defined for the value 1. So what does that mean? Undefined. Because the function g is not defined for the value 1, then g of k of 0 is not defined. This is not in the domain of the composite function. Okay, have a go at these three. A couple of minutes for these ones. Let's have a look now. So, oops, where are we? I'm not sharing anything. Sharing the wrong screen. All right. So we need f of 2. So let's start off with D. So f of 2. We look here and 2 maps onto this one here at 1. So then we need f of 1. So 1 maps onto there, so that's going to equal 4. E. G of h of 1. So h of 1, so when the input is defined at 1, we're going to use this part of h. So that's going to be -4. So we need g of -4. G of -4 we can find here, and we're going to get pi. So this is equal to pi. Pi. I like pi. F, this one's going to take a while. We need f of g of h of k of 4. So firstly, k of 4. F of g of h of, we need 4 minus 2 squared minus 3, which is f of g of h of, what's that going to be? That's going to give us 2 squared, 1. So now we need h of 1. H of 1 we did, that one's -4, isn't it? So f of g of -4. So now we need g of -4, which we did as well. So it's f of pi. -4 is here. How can we find f of pi? Pi is about there, so it's 1. This is our answer here. Okay, let's move on to the last part. It gets a little bit trickier here. So in this bit, we are looking at the domain of composite functions. So here we're looking at the domain. We've got two functions defined. Given the functions f and g are defined above, determine the domain of g of f of x. So let's go back to our function like this again. Here we're going to input our values into f. They come out of f and they go into g and then they come out. So which values are going into f? What is the possible domain for f?
-1, 0, 2.
No? So this is f.
So anything.
What is the domain of this function?
Anything. Anything that's not 0.
This is anything that's not 0. So our domain is coming in here, and it's everything but 0.
Yeah.
What values are coming out?
So you got 3, 2, and 0.
So can we put a number into this that will output a -1? Can we get a -1 out of it?
No, you input -1.
So if we put -1 in, we'll get -1 out, and what will come out of here? 3. Can we get a -4 out? We would have to put a 0 in, wouldn't we? Can we get a 0 out of f? We can't get a 0 out of f, can we? Can we get a 2 out of here? That means we have to get a 1 going in. Can we get a 1 coming out of f?
Yeah. Yes.
What value do we have to put in? 1. Can we get a 0 coming out of here? That means we have to put a 2 into there. What value do we have to put into f to get a 2?
0.5. So 1/2.
A half. Okay. So this is our range, and this is our domain. These are the only values that are going to come through and work. So the domain is going to be given as a discrete set of values, -1, a half, and 1. The range is also going to be a discrete set of values, 0, 2, and 3. Here is our domain and range. From this table, we get this in our range, but we don't get that. Explain to the person next to you why we can't have a -4 in the range of this composite function. Because g has it in its range. Why can't we get it in the composite function? Explain to the person next to you.
Because then it would equal 0.
No, I mean, because we can't have 0 here, that's all.
Sorry?
Because then it would equal 0.
No.
No.
It's more relating to the function f.
Like if you can't merge.
X can't equal 0.
No?
It can't. You said X can't be 0.
Yeah. But
It's through the integration. So when you merge the functions, you put in a 0. That's not work.
no.
No?
Why? Okay. Why can't we have -4? We can't have -4 because we can't put 0 into g. Why can't we put 0 into g?
Because 0 appears the denominator, which then would make the function undefined.
No. That would tend us towards infinity.
Because f function don't have the outcome is 0.
There is no outcome from f of 0. Why not? What would the input have to go towards? F has an asymptote at 0, doesn't it? Horizontal asymptote. It's, what I'm trying to point out is it's not this that's causing the problem. It's the rest of the domain. So the domain of this one is, if I do the full domain, it's this. And it's this bit here, isn't it? If you could put infinity in, you'd get 0 out, but you can't put infinity in.
Because the domain doesn't go to zero.
Because
Infinity?
there is no, it's not a real number. You can only put real numbers in. Infinity isn't real. So you can't put a number into F such that the output is equal to 0, such that then that 0 goes into G in order to give you the -4. Last question. Have a go at this one. Discuss it with the person next to you. Okay, so let's have a look at our answer here for h of x. So what values cannot go into g of x? So g of x, firstly, is going to have a domain of x is greater than or equal to 0. So if we're putting the numbers into that, what are the y values going to be? They're going to be greater or equal to 0. Now, f of x cannot have the domain 0. So we can't put 0 in. So we are going to have all real numbers greater than 0. So our h of x is going to have to be x is greater than 0. Because if we put in 0, we'll be putting a 0 into f of x, and that's not allowed. We can also examine it by finding h of x. H of x is going to be equal to 1 over root x. So if we just look at this function here, clearly x can't be 0, and it can't be negative. So we get C as our answer. All right, have a go at the homework questions. That's it for today.